computer. Okay, we are recording, we are live. Thank you everybody for joining. This is Kubernetes SIG API Machinery, our bi-weekly meeting. Today is May 4th. May the 4th be with you, 2022. And we have a super loaded agenda. Next meeting overlaps with KubeCon EU, so we are going to, in advance, cancel it. So if we have things that we have to follow up, it will have to go to the other meeting. So be mindful of that. Very good. And I will stop talking so we can start doing our business. Mo, do you want to start? You have the first two topics.
Sure, thanks. So on the first topic, I wanted to get some feedback from the folks on this call in particular. So probably before the end of this week, we'll have a KEP out for some proposed changes to the Kubernetes KMS API. One of the concepts that's in there is the ability for the KMS plugin to tell the Kubernetes API server what key it's using, like what key ID, so not literally the private key, but a static immutable unique identifier for a particular key. And I wanted to ask, so the reason for this being included in that change is to make it possible to do key rotation via like storage migration from the outside, like so you can observe it in some way. I am unaware of any status style capability of like API servers for you to probe its state and ask like, hey, basically what level are you? The closest thing I could find.
So just to clarify, are you suggesting that in order to make the key visible, you want to incorporate it into the storage hash that we already publish, so that it appears from outside of the system like a storage version change when you want to rotate a key?
Yeah,
Okay.
with the strong caveat that if you're using multiple API servers, you need some infrastructure specific way of finding all of them and individually making network requests to them on your own, right? Because that's not something there's no guaranteed way to work guaranteed to work across all providers approach to that. Like even if you go to Kubernetes.default service and try to find all the endpoints, it's not guaranteed to give you all the IPs of all the API servers. But
we can't know what sort of load balancers between API server and client. So yeah.
Right. So with that caveat there, the idea is to make that observation of a current key per API server knowable from the outside in an opaque way, so that you can orchestrate this nicely. And one of the other side goals is to make it so you can do something like a key rotation without restarting the API server, which under KMS is very expensive normally because you got to then reload your entire key cache and those types of things.
I have some personal experience with this. Yeah.
Yeah.
I have to think about that. On the one hand, it's kind of nice, but on the other hand, it's kind of so I guess today our storage version hashes, for at least for built-in APIs, have the property that they're constant for a given API server version. Mm-hmm. And this would change that, but maybe that's okay. So this would definitely, from the outside, you would then be able to, like even as just a regular client of the cluster, if you can read the discovery docs, which almost everybody can, you would be able to tell if encryption was on for a given resource because the hash would be different than you expect for that version of API server. Is that a problem, disclosing that? Sorry, you said something, David?
So right now, do we think people learn what those hashes are? I guess they might learn what those hashes are.
You could just go record them all, right? Just run an API server yourself, record them all.
I guess I would ask why you wouldn't be looking at the storage version API that does encode status for how individual servers are storing their data. I don't believe it ever made it to beta, but the design existed, and I seem to recall, I can't remember, is it Roy, who isn't Roy?
Howie.
Oh wait, it's here.
I want to say he was working on it, and like we got stalled at beta, but there wasn't like a fundamental, this won't work, as I recall.
Yeah, I think we've just had competing priorities. So if you can watch and I think the hash is pretty easily accessible. If you happen to like poll it regularly, you could tell when a rotation was about to happen or had happened. I don't know if that is going to be a problem. I can imagine that being a ingredient in an attack, even if it's not an attack by itself.
Yeah, I mean, I looked a bit at the other thing David just mentioned that I'm blanking on, and I saw that it was alpha, and it was unclear to me exactly what it was trying to do and where it was going to go. So I was like, I guess I'll leave this one alone because it's unclear if it's going to graduate or move forward or anything like that.
Yeah, I'm still trying to find an owner for that around here, but it's fairly complicated. So
yeah.
But it would be a status reporting mechanism if it was one that motivated you, Mo, right? Like that design.
The KMS KEP is already large enough as it is. I don't know if I want to pin it on another KEP being done.
Yeah, that makes sense.
Or I guess I would ask this. So the not yet, I mean, it's available publicly because it's just a Google Doc, but the not yet published KEP for KMS proposes a v2 alpha API. It does not try to in place change anything. It's like I just don't want to break the world trying to fix it. I want to leave it alone and do it on its side to give us some space. Would it be okay to have a set of functionality that is only available if you're using this other alpha API? So basically, the rotation thing that I'm talking about could be within that storage version API, but only there if you're actually using it, right? So the idea is that the KMS stuff would be promoted on its own, but you need the other stuff to actually be promoted if you want the nice rotation. That's a thing.
Yeah, I'm sorry I didn't get a chance to read this before the SIG. I guess I thought that this issue was about something else. But I think I need to read the KEP before I form an opinion.
Yeah, I mean, if folks want, I can just in like 4 weeks just come back and be like, hello, please tell me if you have further guidance.
I mean, I'm hesitant to change a mechanism that I think we decided wasn't sufficient for what we wanted to do. And we tried to replace it with this storage version API that I linked in the chat. And to say that we don't want to use the replacement, we want to go back to the thing we decided was insufficient, doesn't seem like movement in the direction that we desired.
Okay, so that's really helpful context. I did not realize that alpha API/KEP is meant as a long-term better replacement for storage version hash. That was not a thing I knew. So that's really good context. So yeah.
So one of the sections in there talks about how after the storage version API is stable, we will remove the storage version hash from the discovery doc.
Okay, that's okay. Okay, so what I'm hearing though is then if assuming the general idea is okay of somehow making observable from the outside the encryption level of a particular resource, the desired place to put that information would be the storage version API thing and not the hash and discovery.
Yeah, the hash and discovery we concluded did not work well. Some of the issues like you're even bumping into when you described it here, where like how do you make sure you get them all becomes impractical from the outside. But if you have an API, you have that spot.
like random users. Everybody needs to know discovery, but not everybody needs to know whether you've got encryption turned on and when you rotate your keys.
Yeah, totally. Yeah, that makes sense. Okay. So yeah, I can take this back, and what I might end up doing there is probably just putting that as a sort of like a undecided change. Like we would like to enhance the other KEP with this metadata. So basically set up the wiring on the KMS side, but not commit to where it's going because the place that it's going isn't done. Does that seem fair?
Yeah, I'll still try and read your the KEP that you mentioned. Can you add a link and or chat it at me so that I have?
Yeah, I can do that.
Okay.
I'll also say that I don't know how much forward progress this part will make unless someone else comes along to help implement it. There is a PR that was a work in progress, and I think it was always.
Okay.
Yeah, probably. Yeah, I can. I've got people around that I've been trying to twist their arms to do this, so I can try again. But yeah, I wouldn't expect this to happen soon.
Okay, that's cool.
So you may need an interim plan, and I kind of agree with David that the interim plan shouldn't be tweaking the existing storage version hash.
Yeah, I was just unaware that y'all want to delete it at some point. I don't want to depend on a thing that's supposed to be deleted. That doesn't sound like a recipe for success.
Okay, cool. Should we go on to the next topic?
Yes. So if y'all want to open the issue, this came up in one of the SIG Auth triages because it touches KMS, but it's really not about KMS in general. It's about how the Kubernetes controller manager does health checks against the API server, in particular because it wants to make sure that discovery is fully populated before it starts making arbitrary decisions based on the contents of said discovery document, as in to run certain controllers or not to run certain controllers or variation thereof. And at some point, this was bumped to basically do full health checks, like all of healths and not any subset of healths. And what that means is, like, if, for example, your Kubernetes API server is functionally healthy from the perspective of KCM, but it's not all the way healthy because, like, it's sitting there loading its massive cache of KMS encrypted data.
Just hypothetically, right? You know.
Yeah. Like in any real environment, basically. Yeah. So then your controller manager is like basically unhealthy because it's waiting for the slowest part of the API server to be done. And Jordan had mentioned, like, he had linked when this was changed to basically cover all of health. So there's like a link somewhere when, yeah, I think that was the issue. So I just wanted to ask, what should we do here? Because it does seem like an unfortunate thing. Like, the proposed issue was like, can you just let me configure the health check that's being made? That seems kind of icky.
I mean, so it's it may not have a simple answer, right? Because some controllers don't need the stuff that has to be loaded into the KMS cache, but other controllers, like the token thingy, probably does need that, or it'll run at a minimum very slow. So it may be the case that one health check isn't good for every controller. You know, not to make it complicated or anything, but
yeah, I guess if there was a specific configuration per controller that basically let it say, this is what I need to be functional before you make decisions on my behalf.
yeah, I should add, just for context, because maybe not everybody knows, but you can pass query parameters to the healthz or the readyz or the liveZ page to exclude certain checks. So you don't have to wait for everything if you don't want to.
So one of the things that came up in the auth call was that discovery is incomplete until a server reports healthy. When you use a load balancer, you really hope that you have it configured right so nothing answers until it's ready. Some load balancers will round robin traffic if nothing is healthy. This produces weird outcomes. The other observation is that the kube controller manager, if you were to recheck, does not have a way to cleanly shut down controllers in progress. And so Jordan had asked, is it possible to have the kube controller manager react nicely to discovery being incomplete or changing or, et cetera, et cetera. And that would take some, I think, significant effort to make something truly dynamic, to turn it off and on. Turn it on probably would not take a huge amount of effort, but would be disruptive. And that would be because joining a shared informer in progress is an expensive stop the world operation. And I'm not entirely sure what that would do to the, say, namespace lifecycle controller that needs to know every resource, or to block owner deletion and garbage collection, which I'd be very happy to remove as a feature, since it doesn't work reliably, but would also be potentially impact.
I mean, if you just treat it like a regular software engineering challenge, it seems like the way you want to go about solving it is like every controller has this has some sort of start function in controller manager. So it seems like you'd want to make them declare some sort of precondition. But right, so it's before you even start it, like wait for something. Like everybody needs you to wait for the lock, for the global lock. And then maybe some other controllers have more specific things, such as what health checks they need API server to be passing. But I agree that that doesn't really solve the problem of suppose it becomes healthy and you start everything and then it becomes unhealthy. What do you do then? I think today we just shut everything down, but it may take a while if we're in the process of starting things up, which isn't good.
So what should we do as like a next step? Should we just summarize the current state of the world into the issues so it's clear that it's not as simple as just making the health check configurable? It's more about a larger issue in KCM itself, but not necessarily the easiest answer.
Yeah, I think there's no like silver bullet. So we'd want to like what is the list of actual specific problems that we need to solve, or the list of requirements that aren't being met, and we may need to separate that out by controller before we can see if there's anything that we can do. Yeah, so I think the answer is it's complicated and we need more precise description of what's going wrong. And maybe the issue has it and I just have failed to read it. I don't know.
In the particular person's issue, it's just that they I think just have a slow KMS setup. So until KMS is all the way happy, Kube Controller Manager is just broken.
Okay. Yeah, I think that might be every KMS setup though.
Yeah.
Once you have enough objects. Yeah, I think that there's probably if we would just do the least or the most obvious thing to fix that, the chance that there'd be some counterintuitive negative effect somewhere else in the system is pretty high. So I think we need a more comprehensive list of what controllers need, what preconditions, before we start fiddling with things.
So I don't feel confident in my own context to write something on this issue that is meaningfully sufficient. Does someone want to take that, please?
I don't know that anyone will be able to do that off the top of their heads, and so it will require actual work.
Yeah.
Unless David knows everything off the top of his head.
I do not.
Yeah, the only other
I'm willing-
person who might have a chance is Jordan.
I'm
But
willing
even Jordan, I don't know.
I'm willing to contribute the things I do know off the top of my head that make this difficult, but I wouldn't want, and I guess I can say I won't treat that as an authoritative list.
Yeah, okay. Well, maybe we
Okay,
can.
if we could just describe the kind of problems that we see obviously, and then like other things to investigate, I think that would at least help anyone who wants to like dare try to pick it up.
Okay.
Okay, I'll make myself a note to
And the intermediate
try and go to it.
are things that I would, independently be in favor of, right? Like if you can make a kube controller manager that can successfully turn off a control loop, that would be really useful. Now, whether that means a kube controller manager at that point is healthy or unhealthy, that's pretty unclear. And we've had difficulty with that since the beginning.
Yeah, okay. We are rapidly burning through our time, so I think we should probably go on. Thanks, Mo. Looks like Steve is up next.
Yes.
Hello. I had sent a doc out a week or a week and a half ago to the mailing list. Do we think that we want to run through that, or do we just kind of want to assume that people have read it and start chatting about things?
I know a number of us read the document in various amounts of detail. Do you want to just maybe summarize what the purpose of the document is?
Sure. So I've been working recently on KCP, where we're trying to think about how to take all the nice things about kube-like APIs, their shapes, our affordances, that sort of thing, and then think about using that in a control plane that's not necessarily for containers and the like. One of the things that we had noticed is sort of due to some of the design decisions put into etcd, there is some pretty strong implications about the system that's based on etcd. One of those is scale. Some of the other ones are more, like functional things about, it being on the user to encrypt backups, look a certain way, that sort of thing. Anyway, so going down this rabbit hole, we asked the question, is it possible to perhaps provide storage for a Kubernetes-like API with something other than etcd? Through our investigation, we identified CockroachDB as being a database where, like at a technical level, it can. And so what that ended up looking like is we've got access to the underlying revisions used in MVCC. And so we're able to map all of the revision requirements from etcd onto Cockroach one-to-one. And secondly, we've got a set of APIs on Cockroach that give us a watch stream. There's a couple differences in the way that watches work, but ultimately, from a technical perspective, you can achieve etcd-like watches. So with the current state of Cockroach, there's a couple performance issues here and there, and the watches are currently they're used for either replication or cold storage or ingest into Kafka, or like otherwise more like high volume cases rather than low latency cases. And so a lot of the things that we look at etcd for, the watch in Cockroach is not really meeting that standard yet. But since it's never really been the point, it'll be interesting to see how that changes. So I guess what I'm interested in talking about and hearing opinions on from this group is, I found this to be pretty exciting. I think it's really interesting. I don't know of another database that's like open and easily runnable off the top of my head that achieved like feature parity like that. And so I guess my first question would be, does the SIG have any interest in doing anything with this? Is there a feature at any point in the KEP project where we want to support more than one storage? And then other ancillary questions would be, so poking at this has been really interesting because it's let me sort of see where etcd-isms have come into the KEP code. And then in places I've been able to update or change tests to be more correct or more specific. And, we're talking about writing a new end-to-end test to validate some of the watch semantics that are undervalidated now. And so I'm wondering, even if, having everyone switch to cockroach, obviously not the point here, but how do we take this opportunity to increase the correctness of our testing and in generally improve the code around storage?
I'd like to respond first, Daniel, if that's okay with you.
Go for it.
I am one of the people that did review this doc. It was very detailed. And I think your first question is the one that I am most concerned about. I see significant value for the KEP project in having a single storage mechanism for the KEP API server. And I think the failure of etcd in 3.5, the bug that they had, is actually a really good example of this, because yes, there was a bug and it was a bad bug. It was a bug we really wish we didn't have. But when we hit it, all the major vendors were right there. We were all in it. We were trying to solve it. There was significant motivation. One person actually found it for all of us. And that value is significant for the community. If instead we went to a model where it was bring your own storage, there would no longer be that shared destiny for us. And that means that that sort of reaction, that sort of bug finding becomes limited. And so I see significant value in having a single storage mechanism. And right now, etcd seems to be functioning pretty well. I'll say that we can scale fairly high, and I do have confidence that if we switch, we will be able to find new problems. But in my experience, switching storage backends is rarely bug-free.
Yeah, absolutely. Yeah. I think that's a huge downside. I will say for what it's worth, the cockroach community has been like incredibly healthy, like interested, supportive. Like some of the things that I noted here have actually been merged and fixed and changed since the document came out. So there is that, but yeah, certainly having one commonality there is a huge plus.
So just at a strategic level, here's the set of things that you could be asking for from the SIG. One is to, I'll try to roughly order this in order of probability. One is to clarify semantics, improve testing, and basically just make it more obvious what requirements we make of both of storage layers and users. I think that many people would be in favor of that. Another thing you could be asking for is for the project to support multiple storage backends. And I think David just made a case of why that's going to be a difficult ask. You could also be making the request that we switch storage ends for everybody from etcd to CockroachDB, which under ordinary circumstances, I'd say has like no chance at all. But if you're to have any chance, this might be the moment. So what are you hoping to accomplish?
Mostly I'm excited that this worked. I don't know of a previous point in time where this could have been achieved with like open database projects. I think the order that you had them is probably the same order that I've got them. At a minimum, being able to like formalize and inspect the way that we use etcd in order to like document those semantics, that would be huge. I think from like as an operator or like a person who runs a kube cluster, I could see many reasons why you might choose Cockroach over etcd, even if it's providing just the same API surface. I think some of the higher level features like, admission control and back pressure, if there's too many writes, or like better user configurable encryption semantics, or like, constant backups, like that sort of thing could be useful.
Yeah,
let me interrupt to just point out that there's at least 3 separate groups of stakeholders here.
Right.
There are us, the developers, and the maintainers of the SIG's code base. There are cluster operators who actually run Kubernetes, and then there's users who use Kubernetes. And I think, for operators, there's like an enormous entrenched user base, right? So there's I don't even have a good estimate for how many Kubernetes clusters there are out there, but those people probably don't want to change unless we give them a super good reason. We don't really want to support more than one storage backend, because that makes our lives, the maintainers, very difficult, and not just a single time, right? Like, I totally believe that you can make tests and get Cockroach DB like at least working, but just getting it working is like only a very small portion of the cost to merging something like this, if that makes sense. Sorry.
No, of course, yeah. And I guess what I was saying is like, I think from an operator perspective, there's like some utility in having that choice. From an end user perspective, the impact is 0 until a point in time where a kube would actually, only support Cockroach. And then you could start doing, I think one of the things I had mentioned in this document is like, in that hypothetical world, adding user provided indices on CRDs or something could be, really straightforward. Users might appreciate that at that point. But yeah, I think I agree with you in that regard, that having a duality here would be much more complicated from a maintenance perspective. I guess I would just say, yeah, I think I'm not aware of a point in the past where it would have been possible to have another database fulfill this technically, like another open.
That kind of depends on how much work you're willing to do.
Yeah,
right. Yeah.
I've
Sorry.
written, like,
With the caveat that like
for old databases. So
sorry, with the caveat that you're not implementing, because like, for instance, with like the really, cool work that kind of is doing, like they're having to, keep track of those revisions themselves. So I think I was mostly coming at this from the perspective of like, hey, this is a place where we can actually get all of that by just using the database the way it's, meant to be used or whatever, and not having to like implement revisions and have to like do another revision layer on top of a database that already has one. So if there's ever a point at which some consideration could happen, I figured this would be it. And if not, then that's probably never going to happen, right?
From your wish list, I'll say that I am definitely in favor of writing better tests to establish what we actually do and does it actually work. I would be in favor, I think one of the things you talked about in the doc is refactors to make those tests easier to write. I could get behind that. In the service of making it easier to write the test, we need to change the way some of the code is structured. I could probably get behind that. Not as much of a slam dunk, but I could probably get behind that. Switching to Cockroach is I'm hoping Daniel sneezed and didn't just like, yeah. switching to Cockroach, I'm not in a place where I want to entertain that. Not right now. I don't think that's a useful use of our developers, and I don't think that will serve the project well.
Yeah, and I think in
Yeah.
general too, like Cockroach right now doesn't, even provide the same watch event throughput. So that, the only point at which I would ever ask that question would be if it were, strictly better in all cases, and the switching cost is part of that, right? So I don't think that's what I'm asking for here.
Yeah, I think I wouldn't say like the requirement would be strictly better in all cases. That might be setting the bar a little too high, but yeah, the migration cost is just unbelievably enormous. So yeah, the bar is higher than that in other senses, right? Actually, the lesson that maybe I'm taking from the not just this, but all the like the recent Etsy debug, et cetera, is that maybe we in API Machinery should pay a little bit more attention to etcd, and maybe that means implementing some features to make indexing slightly easier, or maybe that means adding some safety features to prevent additional similar bugs. I'm not sure, but I just like the more I thought about this, the more impossible a migration of every cluster in the world seems. Like I just can't imagine. We'd have to make like a special version of a database that understood both etcd and CockroachDB state, and yeah, it would be a nightmare. But there's things we could do in etcd to potentially make adding database features much easier. So, and that seems much more palatable from a migration perspective. I don't know. What do you think, David?
Yeah.
I'm throwing David a curveball here.
Yeah. I do think that would probably be more palatable. I will say I want the tests that Steve talked about first. I know of at least one he mentioned in here. I don't know.
Yeah, I think he already made a PR. I saw something in my email, but I haven't looked at it.
I don't see Han here. Oh yeah, there he is. But Han has also mentioned separately, like semantics were not super well defined, and it sounded like either Han personally or Google has taken an effort to understand what those are. And I think writing those tests into Cube or into etcd or into both could have significant value for all of us.
Yeah, I'd also say like in terms of performance and scale, I think there's actually lower hanging fruit, especially around listing and watching, right? Like if we made, for example, I've opened an issue a long time ago just outlining how you could have API server and a client sort of figure out what the client already knew and send the delta between them instead of sending everything when you need to do a relist, right? Like that's sort of, I think there's a lot of potential in that direction, just because our relists require the entire object to be sent and the objects to all go in serial. And actually making them go in parallel wouldn't help too much. There was an issue about that over the last couple of weeks. But because API server is doing many lists at a time, like just parallelizing everything, eventually you run out of network bandwidth. So I think there's a lot of there's a lot to be gained from improving the efficiency of what we like, not sending redundant bytes. I think we do a lot of that right now, and like from that perspective, I think that can be improved.
I think I remember seeing a streaming proposal as well. Like,
yeah, that one from Polynomial was I thought pretty compelling.
Would you guys be open to a KEP that proposed refactorings in the storage layer to make it more clear the semantics that we use from etcd?
Possibly. I'm really interested in being able to test what we have.
Yeah, I'm not proposing that we switch over to Clockwork TV or anything like that. I just want it to be explicit, the contract that we have, that we use with etcd, because right now it's just implied in our code. And you would have to traverse the storage layer and figure out exactly what it is, the surface area that we use against etcd, right?
I guess I'd ask Steve since he went through and did it.
Yes, that is absolutely true. And I think, so from the comments that were made in like 2007 or 2017, sorry, last time some of this was being debated, I remember seeing a lot of reservations from SIG API Machinery at the time, wondering which features from etcd they would use in the future, and keeping things open in case that changed. I don't think anything major has panned out since then.
No,
Well, so I think the deal there is there's a difference between API server using a feature and exposing that feature to users. And we're always going to be extremely cautious on that second category. Like, yes, etcd3 can do transactions now, great. That does not mean we're ever going to let users do transactions between multiple objects, right? That might mean that API server could use etcd transactions to keep indexes in etcd.
Sure. Yeah, sorry, I just meant more like, it seemed like there was a lot of uncertainty at the time about what the actual API surface was of etcd that we wanted to use and think about. It doesn't seem like, it seems like that's stabilized, and so this might be a good time to try to make that more formal.
I'm not prepared in this meeting to say that I will never want to make use of another etcd feature. So if that's coming through, I'll be very.
I am definitely not saying that. Like, if there was an interface introduced that, explicitly laid out the API surface that we're using in etcd, I would expect this to be internal only, right? Like, we don't want to stop something like bookmarks from happening, right? Because there are obviously a lot of performance gains that we got from bookmarks. So specifically, this would be just to make the semantics clear and explicit.
I guess I'd ask Steve, do you think that would make it easier to test? Probably. I don't want to lose sight of that as probably the next most valuable goal.
Yeah, I
think at least the most valuable goal I got out of Steve's doc here.
One of the things that came up recently, Jordan and I were looking at one of the existing storage tests, like whether or not it's intentional, like a bunch of them have implicit requirements about what happens when you ask etcd for something. And I think making that explicit and having like an internal only interface that made that contract more visually obvious. Like, I don't think there's anything stopping us from running the tests now, but I do think that it might, like, as it is existing today, a lot of these tests are either implicit or very hard to parse. And so I think there's definitely, without giving it more thought, I think there'd be some benefit to having a more explicit internal only interface that just helped us document this.
Okay.
And the tests would be clearer. But I think we can probably, I think this out a little bit more.
That might depend on the specifics of what was up for change, but it sounds like in service of that goal. Yeah, I could see doing that.
And I guess we could probably morph this into the next item on the agenda as well. And I don't know if Wojtek is here, but he had began talking to me about this because he was working on the watch cache pagination item. But I think in general, there's a slightly perplexing situation right now where we actually don't have any tests for storage.Interface. The only tests that we have written are for explicitly etcd, that implementation of it. Some of the downsides of that is we end up testing like very storage level things at the integration level, because that's where we can exercise the watch cache on top of the storage and get both of them at the same time. One of the things, sorry, go ahead.
I was gonna say, I think there's actually a deliberate reason for that, which is we had some tests, and we still have some tests that involve like fake storage or whatever. And an issue we had very early on was that the properties of our fake that was used in the test diverged from the properties of etcd, the storage layer. And so like the tests would pass and then not give the guarantees that you thought because you weren't actually testing the right thing. So
I think I
I
was
think
saying it in the other direction. So the test that validates that like list does what you want would be something that we could run against a generic storage interface, whether that's the etcd implementation or the etcd implementation underneath the watch cache. And both should return us the same result.
yes, if you had a perfect suite of tests, then you could have an in-memory fake which passed the tests, and you would be confident about it. I'm
sorry,
skeptical that we can.
I'm not saying an in-memory fake. I'm just saying like the test that validates the semantics of the get method currently expects that to run against the etcd implementation full stop, even though every implementation of the storage interface should pass the same test. We don't test any of the other implementations. And one of the downstream effects of this is in integration today, we actually pass around an etcd client that knows how to do compaction, which is more of an etcd client than we even use in the storage itself.
When you say the other implementations, you mean like the caching object implementation
Yes.
and the indexing thingy implementation?
I will say being able to test the watch cache better would be pretty compelling.
Yeah, that seems pretty useful.
So that's what we were talking about here. There's a couple like weird, I don't know. There's a couple places where like the current tests are expecting the etcd type. They're messing with its fields. They're doing some really low level stuff, and so those tests may or may not be easy to work. But quite a
that's
large
fine.
number.
Like you don't need to test that the watch cache can do compaction, right? That doesn't make any sense.
Right.
So it's fine that not all features get tested on every implementation.
Okay, so but there is like this large corpus of tests where if you just change the type of the thing it's testing, it works fine with the watch cache. And ideally we'd be okay refactoring that and then adding a second suite of tests. And then
Yeah, that sounds super useful to run the watch cache through the same set of tests that we put etcd through. Yeah, that sounds great.
What we don't have are a series of tests which test that etcd is actually conforming to the interface that we expect it to be conforming to, because it is possible that like etcd 3.6 rolls around and basically they do something to global revision that basically invalidates huge assumptions that Kubernetes has about the underlying storage layer, right? Like,
yeah, I'm sorry, Hannah, I didn't mean, I had moved onto this different subject. I didn't mean to cut that one off.
Oh.
Yeah, and that's kind of what I was saying is like we could theoretically write those tests today just using like the raw etcd client. Like I don't think we need an interface, so to speak, but like making the interface there would make it much more explicit, much more intentional, and much less like, right now these are so hard to read.
Yeah, I mean, like you gotta the interface at least takes care of some of like getting a client to it and abstracting that sort of stuff away. So I think it should be fine to do most of the testing through the storage interface.
So for some of these refactors, do we think that a full KEP would be necessary for both? How do we want to propose the work and agree on it?
We normally require a KEP for refactors.
Yeah, if you're just improving testing, I don't think we need a KEP for that.
Yeah.
Okay, Han, maybe we can open a tracking issue then and get some general agreement on the direction there.
Yeah, that sounds great.
I would like to keep the goal in mind, right? I really like Khan's point about 3.6. Yeah, I want to have a suite of Cube expects this and to have that run when we update again. I think that would be really helpful.
Yeah, between that and then also checking that the watch cache passes everything.
Yes.
those were like the biggest places. Some of the other work that I had done over the last couple of months is just removing. There were quite a lot of tests all the way up to E2E doing bizarre math on resource versions and stuff where they just shouldn't have been. And that has also been like a place where the cockroach work just has fallout that's useful. And should make those more resilient.
All right, we've got 8 minutes left, which sounds like it's not enough time for our cache busting demo.
Sean here was saying that he just wanted to show a couple of slides that is about 2 minutes or so. Is
okay.
this link?
Yeah, that'd be great. So actually the first link there is the design doc, which is in the process of being moved to a KEP. And of course, we're asking for this group's feedback on that design. But I just wanted to go over to give some context. We're not going to have time to do the video demo, which is the third link, if you want to check that out on your own. But if we could go into this, there's only 4 slides here. And what we're proposing is a more efficient discovery mechanism. And we think that we can do this better with using cache busting. And so we probably don't need to go over this first slide with this audience. Everybody should already know this. But what problem does cache busting solve? Well, we're caching this information in kube control. It's disk cache, and for controllers, most controllers, it's memory cached. But there's no mechanism to signal clients when this discovery information is out of date, when it's stale. So the current solution is to basically just request all of the entire set of APIs after some amount of time. And for the disk cached client, it's 6 hours, used to be 10 minutes. And so what we end up with is this very inefficient system where the discovery can be out of date and is re-requested on regular intervals when it doesn't need to be. And so cache busting should solve this problem, where we will never have APIs which are discovering information which is out of date. Can we go to the next slide? And this is the final slide, which is the 50,000-foot overview of what cache busting is. And it's basically the initial root API query is going to return a hash for the group version so that we can tell when a particular API is out of date for the secondary query for the API. So that was the really quick version. Why don't I just open it up to questions?
I'm wondering whether this was compared against the idea of saying, what we really want is a different discovery doc. We wish we had discovery all in a single request with an E tag. And comparing that instead so that you never had 200 requests. It was a single request, and then in the case where there was no change, you just sent the E tag and got back a no change.
So we haven't considered that. So my understanding of the E-tags, and one of the reasons why E-tags is insufficient for the two-step process, is that the actual, it doesn't reduce the number of queries. And because most of the data which is being returned is so small, you're really not getting much of a, at least for this two-step process, using E-tags to say, whether or not there's been a change doesn't really buy you much. So, but with a one-step process, off the top of my head, I'm not 100% sure.
I think also another part of the issue is that, like, why every time I install a CRD, why should I re-download the discovery info for everything, for pods and for everything else, right? I mean,
which would have to happen for the for the one API mechanism, the one query mechanism.
Have we considered watchable discovery?
So that actually sounds like, I think that there has been quite a bit of talk.
This is a different problem.
Yeah, sorry.
Yeah, the cache busting proposal is pretty cool, actually, David. If you haven't seen that before, it's basically like you download an index each time, which is just a list of links, and then most of the links don't change, and so they're already in your cache, and you don't have to get them. Yeah. And if the index hasn't changed either, then you just don't even have to download that. You just get back the whatever 304 or whatever it is.
I think it's probably worth at least explaining why it would be better than say like that first alternative. Like I'm reading this and the very first thing that pops in my head in 30 seconds is why not do this? So.
Okay, we'll do that. Thanks, David. And if anybody would like to see a demo of this, we built it on a particular branch, and we've got a video demo of how this would look.
Is this linked?
Yep, it's that final link. If anyone's
and also, does it describe how it handles aggregated API servers?
Yes, it does. So
Okay.
in fact, the code on our branch works for aggregated API servers as well. And yeah, that was actually one of the more difficult parts to implement, was to plumb this hash all the way through the aggregator.
All right, I think we are out of time. Shyam, can we get your issue or your question next time, or you can ping us on Slack maybe?
Hey, yeah, sure, that works.
All right,
Thanks.
thanks.
I'll
Sorry.
just move my item to the next sync whenever
Okay,
I think it's after KubeCon.
Yeah. Sorry, it was a really packed agenda.
No worries. Thanks, Daniel.
All right.
Very good. Well, thank you for the discussion. Safe travels if you're going to KubeCon Europe, and we'll see you again in 4 weeks. Thank you, everybody, for coming. Have a good Wednesday.
Bye.